Bismillahirrahmanirrahim. Assalamu alaikum. I welcome all of you to the week 7 virtual session of the course of Introduction to Information Systems. In this week we will cover chapter 6 of our textbook. But before we start studying chapter 6, let me tell you that by the grace of Almighty Allah, now we have faculty members on all of the campuses for this course. So if unfortunately you did not have any teachers so far for teaching this course, at Riyadh campus, Ms. Basma has been teaching this course. At the Mam campus, Dr. Nida Aslam will be taking this course. At Medina campus, Mrs. Shazim Anjum will be teaching this course, and at Jeddah campus, Mrs. Anwar Bani Nasser will be taking this course. So you have your face-to-face teachers, and I hope that all of you have started taking face-to-face classes with them. In these virtual lectures, you can see that from the recordings you can get content about chapter 1, chapter 2, chapter 4, and after today's recording you will also get the recording of chapter 6. Chapter 3 and chapter 5 are not present on the blackboard. So if you have not studied those chapters so far, you can ask your teachers to conduct lectures for chapter 3 and chapter 5. If unfortunately they cannot take these chapters, you can email me about that problem, so that we can create sessions for those chapters as well, so that none of you is left behind. I have said that you have now teachers at your own campuses to conduct face-to-face classes. In these recordings you have recording for chapter 1, chapter 2, chapter 4 and chapter 6. You can ask your teachers to cover chapter 3 and chapter 5 for you in face-to-face classes, but if unfortunately it cannot be arranged, you can send me an email telling that chapter 3 and chapter 5 have not been covered, so that we can create another virtual session where these chapters, I will cover these chapters for you. You have done till chapter 4. Chapter 5 has to be done by your teacher in your face-to-face class. I am covering chapter 6 here. Chapter 5 will be taught to you by your own respective teachers. So here we will cover chapter 6 today. We are not covering chapter 5. Chapter 5 in Riyadh will be taught to you by your teacher, Ms. Basma, inshallah, at Riyadh campus. So you will all be at chapter 6 at the end of today's chapter. After this week, we will at the Mam campus, Dr. Nida Aslam will start taking face-to-face classes, inshallah. If she hasn't taken already, she will start taking from next week. So now your midterm, inshallah, whenever it takes place, I don't know the date of your midterm exam, but whenever it takes place, with collaboration of all of the teachers, your midterm will be till chapter 6. This is half of your book. So till chapter 6 you will have your midterm. Whatever chapters that we cover after this will be after the midterm. You should study the lecture slides very carefully. You should understand all of the lecture slides and also cover the case studies from the book. If you understand the lecture slides from the lectures and only case studies from the book, that will be sufficient for you. But make sure to attempt the assignments that are given on the blackboard. These are very simple assignments. You will be able to easily do that if you do these 3 things: read the lecture slides, case studies only from the book, and do the assignments. Then your content is properly covered. You don't need to study anything. So now we are starting our chapter 6. The chat will be closed now, and we will cover the chapter. In the last 5 minutes, we will take last 5 to 10 minutes. We will take the
تم
questions.
بدء التسجيل.
I will tell you about the parameter of the exams. On the blackboard there are some assignments that you should do. These are very easy assignments. If you do these assignments, you will prepare your paper in a very good manner. So now starting chapter 6. Chapter 6 is about telecommunication and networks. You see, starting from the first slide of the book, you see that assume you are working in an organization where 500 people are working. Now these 500 people are working on their own computers. They don't have any network with them. It means that everyone is working on his own. No two people can collaborate with each other, can communicate with each other. So if you are working on your computer and then you want someone else to do some more work on what you have done, what will you do? You will take the data on USB and go to that person, give him the USB so that he can copy it on his computer and do the work. This will waste a lot of time and your efficiency will be compromised. On the other hand, if all of these computers are connected together, in that case you don't need to go to that person. If you can create a network of 500 computers, all the 500 people working on those computers can work together. So the communication becomes fast, number one. Number two, if you are working on your computer, you only have the resources of your computer, your own hard disk, your own processor. Other computers are of no use to you. But if you create a network, all of these computers merge together to form a very big resource, a very big hardware, a very big processor, a very big infrastructure, which all of you can take benefit. You see at slide number 6, what is networking? Networking is merging the resources together. If you merge the resources together, you can get benefit of all of the resources. If you don't merge the resources, you can get benefit of only your small resource. This is called stacking. When you are doing networking, you are stacking the resources. You are merging the resources with the help of a network so that your work becomes fast and you get more computation power. You get more resources at your disposal. That is the purpose of doing networking. When you create a network, it means that you are not just adding. Like if you create a network of 3 computers, it does not mean that you have only increased your power of computers to 3. McCall's law, given on the slide number 7, says that when you create a network, the power of network is equal to the square of number of computers present on that network. It means that if you have a network of 2 computers, the computation power is not 2. Computation power is 2 raised to the power 2 equals 4. If you have 3 computers, you don't have the power of 3. You have the power of 3 raised to the power 2 equals 9. If you have 4 computers, you don't have the power of 4. You have the power of 4 square, 16 computers. So when you do the networking, more computers on the network means the scale of those computers. The power increases manyfold. That is the power of networks. When you do the networking, you are enhancing the power of your organization manyfold. It is because when you are using only your computer, at any given time, you are using maybe 10%, maybe 15% of your computer's resources. But then you have created a network, not only you are using the computation power of your computer, you are using the computation power of all other computers as well. So before network, if 15% of your computer was being used, with the help of networks, your computer's computation utility becomes 50%. 60%, because now others are using your computer as well. So now your processing power not just adds, it multiplies. It becomes many folds. This is given in slide number 7. Why more and more organizations are going for internet is given in slide number 8, 9 and 10. As you see, there are 3 major reasons which are forcing the internet and networks to be implemented in every organization. One reason is industry. As you see, more and more organizations are becoming network dependent. You will see in any organization, if they don't have their own local area network, or if they don't have any internet with them, they at least have internet connection. Everyone communicates with the others using internet, using the support provided by the internet. Large organizations are using networks to communicate data between their sites. And this trend is vastly increasing. So one reason why networks are becoming so popular is because it is the demand of the industry in which we are working. Second, there are many applications today which require the provision of internet. You see, even if you look at your smartphone, all of the applications that you have on your smartphone require provision of internet. For them. If there is no internet, those applications become useless to you. So applications require internet. That is second reason why organizations are networking themselves. The third reason is that internet is evolving itself. Internet is becoming so powerful, internet is becoming so equipped with new technologies that every organization is using internet. So if you are using internet, you need some kind of network to use the internet. You see slide number 9. You see internet networking technologies are becoming more and more efficient, more and more reliable. Internet networking technologies allow you to communicate openly. These are called open systems. Internet is open. Internet is available to all of us. All of the technologies which are present on internet are independent, are accessible to everyone. These are not restricted. These are called open systems. So if you are using internet as your network, you are working with open systems. But if you are using intranets or you are using extranets, then you are not using open systems. Then you are using applications which run on your intranet. We will talk about intranet in a small while. So for intranet, you will have your own dedicated applications. For internet, you have applications which are accessible to everyone. Just like Blackboard. Blackboard is an open system because with this Blackboard, we are communicating with each other on intranet. Blackboard is accessible to everyone. It is accessible to me, it is accessible to you, it is accessible to any other organization as well who buys it. But if we created an application which was only for our own university, then it would not be an open system. Now, if we use networks for operations of our organizations, we have to understand that networks communicate between many computers. Now these computers may be different from each other. These computers may have different applications on them. Some computers may run on Apple Macintosh operating system. Some may run on Linux operating system, for example, and some may run on Windows operating system. When you run Windows operating system, you run Windows applications. And when you run Linux operating system, you run applications which are based on Linux platform. So if you create a network, how do you ensure that all of the machines can communicate with each other? If you create a network and you let your users, you want your users to use many applications on different platforms, then you need another software which can help these different platforms communicate with each other. It is called middleware. A middleware is a software which helps communication between various softwares. particularly when these softwares are being used on a network. So if you have a network-based application, it must run on a middleware. It is a very essential part of network-based network-based information technology. So we talked about the middleware. Slide number 10 gives a summary of whatever we have talked today. In all, why networks are becoming popular? Networks are becoming popular because number one, the cost of using networks has reduced. These reduce the cost of doing operations. Number two, the network technologies have become very efficient. The response time has reduced. Number three, with the help of network, we can collaborate with each other while sitting on our own desk. So collaboration increases. And with the help of networks, we can do e-commerce, we can do business. You see, there are a lot of applications which are running a very huge amount of business using networks. For example, e-commerce site of Amazon. For example, various kind of messengers. All of these applications are generating revenues using the network technologies. Today we have an internet revolution in which most of the businesses are earning revenues from the network. These are reasons: cost reduction, better response time, improved collaboration between the users, and e-commerce. These are forcing the organizations to transform them from small organizations to network-based organizations. The business value of using networks is very immense. Now we come to the various kind of networks which the organizations use. The first kind of network given on slide number 13 is intranet. So now let's talk about what intranet is. Intranet is a network which is developed using internet technologies. You know what are internet technologies? Internet technologies are Java, Apache, PHP, ASP.NET. These are various kind of technologies which are used to develop internet-based applications. So let's suppose we create a network which is developed just as internet has been developed. But this network is only accessible for our own organization. So you can say that intranet is a small internet. A small internet which is private, which only our organization uses. If my organization is such that I don't want the people from outside the organization to access my data is my property. It is very precious because if it is stolen, it can be used for any other reason. So for the fear of my data loss and for enhancing my processing power, I create a small network of my own, which is accessible for my own organization. This small private network is called intranet. As you can see, intranet is a private internal network based on the same internet technologies. But it is private. It is like internet is a very large pie and I create my own small pie, so that whoever uses internet cannot access my small pie. This small pie is intranet. Intranet is vital for those organizations which want to keep their communication and data secure, number one. Number two, with intranet, I'm making sure that my bandwidth is only dedicated to my own organization. On internet, I don't know because internet is open. Everyone is using internet. Internet can break down anywhere. Internet is not my organization's property. But my intranet is my property. So if I create an intranet, it means I am managing my own network. So all of the communication, all of the collaboration is secure and efficient. And at the same time, using this intranet, I can automate the processes of my organization. I can do publishing on the intranet because I don't have any fear that someone from outside can access the data that I am communicating on the intranet. So overall, it's a very useful network that organizations use, but creating our own intranets are expensive. Intranets can only be created by those organizations which have a lot of resources at their disposal. So when you will read the case studies, you will also see how these intranets help organizations. The second kind of network is extranet. Extranet is also a kind of, yes, it is actually intranet is an internal connection for one company, for one organization. Now, if I have created an intranet, it means that that intranet will be used by only my organization. But then you have to see that every organization also communicates with many other organizations. For example, there are some customers who buy products from my organization. They are not part of my organization. If I have created intranet, they cannot access it. There are some vendors who supply products to me. But if I have created an intranet, they cannot access my intranet. Now, if I create a private network, an intranet, using internet technologies, but then I open that intranet to only a selected group of organizations or people, my vendors, my customers, my authorities. Intranet which communicates with some, not all. It is my private network, but it not only works in my organization, but with those organizations with which I do business. Then my intranet becomes extranet. Extranet is an intranet which communicates with related organizations with which I choose. So if I use extranet, it enhances my value because now I'm not only doing my internal processes using my intranet, I'm also communicating with my customers. I'm also communicating with my suppliers. I'm also communicating with my vendors. I'm also communicating with the government. So utility increases, but at the same time security decreases. Because when I only had the intranet, only the people from within my organization could access it. The others could not access it. So it was very secure. It could have only been breached by the people inside my organization. But when I make it an extranet, the people from outside my organization can also access it. Because now I have open communication with them. So now security of my network becomes more vulnerable. You can see on slide number 16, this is the example of an extranet. You see, I have created an intranet, inter-networked enterprise in the middle. And this, yes, you can say that extranet is an intranet which is made by me. It is an internal network and can be accessed by only the people that I choose, not everyone. Internet is accessed by everyone, but extranet is only accessed by those which I choose. So this is slide number 16 is an example of an extranet. My intranet communicating with my partners, my consultants, my contractors, my consumers, my suppliers and my distributors which I have chosen. Not everyone. But still, since now I am communicating with all of them, it means that my network can be breached from any of these as well. So security decreases. This is the disadvantage. So just as intranets are expensive, similarly extranets are also expensive. Not many organizations can afford to get their own intranet or their own extranet because these require a lot of money and a lot of technical resources for these. So again, there is a case study of NFL on slide number 17 that you will study. In section 2, we are going to talk about further terminologies from slide number 20 and onwards. Now on slide number 20, 5 basic components of any network have been described. Number 1, terminal. What is a terminal? A terminal can be or cannot be a computer. A terminal is a window, an interface through which you can give data on the network or you can receive data from the network. So for example, you go to an ATM machine, that ATM machine is a terminal. For example, you go to anywhere where, for example, in hospital, and you wait for your term, and for that term you generate a receipt, a number for you, that is a terminal. Your computer can be a terminal. A terminal can be an intelligent computer, means a computer with a processor, or it can be just a screen like an ATM machine. What is an ATM machine? ATM machine is a dumb computer. All the networking is done at the server side. So terminal is a device through which you give some data as input to the network, or you receive some data from the network on the screen or on the printer or anywhere. Telecommunication processors are the computers which put that data on the network. For example, servers. Servers are your telecommunication processors, data servers, network servers. These are called telecommunication processors because these are responsible for sending the data on the network. You see, when you are using internet, using your computer doesn't know how to send data to the internet. But modem connected with your computer is a processor which transmits that data on the internet. Your computer doesn't know. Your computer is just a terminal. But modem is a telecommunication processor. A switch is a telecommunication processor. A router is a telecommunication processor. An adapter is a telecommunication processor. These are tools which support data transmission, which send data and receive data from one place to another place on the network. Telecommunication channels are all of those mediums through which data is transported from one place to another. So, for example, fiber optic is a telecommunication channel. Wireless technologies are the telecommunication channel. For example, Bluetooth is a telecommunication channel. For example, cables, telephone cables are telecommunication channels. Computers are intelligent terminals which send and receive data from the network. And telecommunication software are network applications which manage your network. So overall, all of these intranets and extranets and internet, all of these are divided into 3 major categories depending on the size. Networks can be divided into 3 major categories depending on their size. The smallest kind of networks are called local area networks. So, like if you see, you are working in an organization, in the organization all of the computers are connected. That network, within that organization, that small building, a local area network is a network which is put in a small defined building, in a short distance. So for example, in your campus, when you use a computer or a lab, all of the computers in that campus, in that boundary, in that small geographic boundary are connected with each other, and then there is a cable which is connecting this building with all of the other networks. You see, when you are at your home or when you are at your office, there is a communication which is done within the building, and all the communication from within the building goes out using network communication method. So that small building network, which is within a small building, a small geographical entity, it can even be your home. A network which is established in a small area is called local area network. A local area network at most covers one building. When network goes out from that building, it means now it combines with other local area networks. So when you combine many local area networks within a particular geographical boundary, for example, all the local area networks of your city, of Medina, of Dammam, of Jeddah, of Riyadh, when you combine the local area networks of one whole city, all of these networks combined become metropolitan area network. So local area network is a network which is limited to a building. Metropolitan area network is a network, yes, metropolitan area network, MAN, is a network limited to a complete geography, a small city, a large city, any city, but it has its limits. So building, land, a city, metropolitan area. And when you combine many metropolitan area networks together into a very large network, for example, the whole network of Kingdom of Saudi Arabia, it becomes a wide area network. And you keep on growing it, so you see the largest of the wide area network is World Wide Web, Internet. Internet is a wide area network of the whole world. You can have wide area network. This wide area network combines several smaller wide area networks of each country. Each wide area network comprises of many metropolitan area networks, and each metropolitan area network combines many local area networks. So you see a LAN, this is a LAN given on slide number 22. You can see it is combining the computers within a building. Now the advantage of LAN is that not only these computers can communicate with each other, you can see each computer can communicate with any other computer, but also now all of these computers can share the combined resources, shared databases, shared applications, shared printers, shared scanners. Now all of these computers on LAN can also use these shared resources. So this is the advantage of LAN. And then LANs communicate with each other to make MANs, and MANs communicate with each other to make WANs. So far we talked about the intranets, extranets. Both intranets and extranets were for the organization. But we said that intranets and extranets are very expensive. So what if an organization wants to secure their communication but cannot afford to develop intranets and extranets? What do? They create virtual private networks. Yes, they create virtual private networks. So what is a virtual private network? Virtual private network is, you think of internet as a very large pipe. So in that very large pipe, all of the data that we are sending is traveling with each other. And all of that data can be accessed by anyone sitting on the internet. Now let's say that in that large pipe, I purchase some space and put my own small pipe in that large pipe. And I put my data in that small pipe. Now my data is traveling on the internet but is insulated from all of the other internet because I have secured it by putting my own small pipe in the internet. Now my data is traveling on the internet in a small allocated space that I have purchased. I have created a kind of tunnel in the internet, and in that tunnel only my data is traveling. This tunnel is called virtual private network. So a network that uses internet, but within that internet it only allows its own data to travel. No other data can travel on this particular network. This is called virtual private network. Now virtual private networks are secure than the internet. but not as secure as intranets and extranets, because still that tunnel is traveling within the internet. Since it is traveling within the internet, so anyone can try to break the tunnel. You see, when internet was a separate pipe and your intranet was a separate pipe, the people traveling on the internet did not know that your pipe exists. But now when you have your virtual private network tunneled inside the internet, all of the data traveling on the internet knows that this tunnel exists. So they can try to break the tunnel. So it is secure than the internet, but not that secure as intranets and extranets. Client-server networks manage the client-server applications. Client-server networks are such kind of networks in which there is one server, one or more servers, who have all the processing and all of the data. These servers are connected with clients. Clients are dumb computers, means they don't have any processing with them. They don't have any data with them. These clients only receive data from the user or display information to the user. Clients receive data and send that data to the server. Server uses that data, processes the information and sends the information back to client where it is displayed. So all the processing is done centrally. It is the server which is doing processing, which is maintaining the data, and the clients are only displaying. So this is client-server networks. There are other kind of networks which are called peer-to-peer networks. In peer-to-peer networks, all the computers connected are processors. So there is no server. All computers can do their own processing, and they share their processing with each other. So peer-to-peer networks, all the computers can work. In client-server networks, only servers work, while clients display the information. Network computing is that kind of computing which is done on the network. So all of these applications which run on the network do the network computing. Google Docs do the network computing. All the messengers do the network computing. If you have any other applications which run on your computer, or your machines, your smartphones, which use internet, they are all doing network computing. So network computing can earn profit for you as well. We already talked about peer-to-peer networks. Now we should talk about how the data travels on the network. Now the data that travels on the network can be in two forms. One is analog, the other is digital. You see, when you communicate using your telephones, the classical telephones that we had, which have copper cables associated with them, the data that is transmitted from our telephones is analog in its nature, is in the form of a sinusoidal wave. Right? When your data is in the form of sinusoidal wave, it is called analog. It is continuous. It is not discretized in the form of zeros and ones. You see, when you talk of bit operations, these bits are independent from each other. Each zero is separate, each one is separate. But when we have analog, we don't have zeros and ones. We have a wave of data, a continuous data. So, for example, these telephone networks at the user level are analog. When we pick up our telephone and when we are talking, this data is analog. Although when this data reaches to the telephone company's communication channels, it is discretized, digitalized. So analog data can be in the form of a frequency which can be from 20 Hertz to 20 kilohertz. So telephone technology uses analog data. The computers, on the other hand, use digital data. So if you want internet, then the data that you will send from your computer will be in digital form. But if you are using a copper cable, with the help of a modem connected to your computer, that copper cable will take analog data. That is where modem plays its role. Modem converts the digital data into analog data. You type on your computer, it is digital. It goes to the modem. Modem transforms this digital data into analog that copper cable can understand, so that it can travel on the copper cable. And when this data reaches to the computer again, there again is a modem. It takes the analog data and transforms the data into digital data, so that computer can understand it. There are two kinds of data. That is what we are talking. One is analog and the other is digital. Analog is continuous. It is not bit based. It is wave based, which has a frequency from 20 Hz to 20 kHz. And computers use digital data. That is bit based. It is divided into zeros and ones. This division is called discretion. Media is the communication channel, the paths that we create for the networks. You see, there are many kind of communication media available today. For example, the most classical kind of was the copper-based wires twisted with each other, which our telephones use. These are called twisted pair wires. Then there are coaxial cables, the cable which is one cable, not two cables. One cable which is insulated, like you see for your televisions, you use coaxial cables. For your television communication, you use coaxial cables. Then there are fiber optics, which are much faster than both coaxial and twisted wire. And then there are wireless based solutions as well. Whatever technology that you use, the problem is the problem of last mile. You see, whatever technology you use will be more efficient if it delivers data to the end user of the network efficiently. That end user of the network is called the last mile. So when we use coaxial cables or twisted wire cables, there the last mile was poor because they delivered data to the end user very slowly. The data was lost. You see, if you use telephone-based networks, the data reaches to your computer slow. It loads your web applications very slowly. But if you use wireless, the data reaches to your computer very fastly. You use satellites or you use fiber optics because they are more efficient for the last mile. Last mile means the end users. Your internet service providers put better and better solutions, fiber optic solutions, wireless based solutions, satellite based solutions, so that the end users can get better quality, so that the last mile gets the data in a better and efficient manner. This is called the concept of last mile, which is discussed in slide number 28. So we have twisted cable media, we have coaxial cable media, we have fiber optics media, and we have wireless technologies. So in wireless technologies, you have terrestrial microwave, the kind of technologies which uses tower. So you see your wireless providers install towers, and from these towers the data is transmitted from one tower to another tower. These are called terrestrial microwave solutions. Then there are satellite based solutions where you transmit data from one very large transmitter which are in the form of satellite receivers to a satellite, and then satellite transmits that data to another source which is working as receiver. All of that data, this is also very fast and very large. Then there are cellular technologies like GSM technology, CDMA technology. These are the technologies on which our mobile phones run. Many organizations install switches and routers which are wireless. So when you, for example, when you go to your university, you can access wireless from your laptop. from anywhere. You don't need any cable. These kind of LANs are called wireless LANs. Bluetooth itself is a wireless technology because it doesn't require any kind of physical communication medium. Any technology which does not require any physical medium or wire to send data from one place to another is a wireless technology. Technologies of tomorrow will be more and more wireless, will depend less on the medium, on the physical medium, and will convey data wirelessly from one place to another place. So we have already talked about the modems. What are modems? Modems are the devices installed with our computers which change data from analog to digital and from digital to analog. Without modem or some kind of technology which uses modem, you cannot transmit data on the cable, because when you use cable, you need analog signals. If you are using wireless, you don't need modem. So for wireless networks, there are no modems. You see with your notebooks, there is no modem because you are using wireless technology. But if you want to connect a wire with your computer needs to have a modem. Then there are internetwork processors. These are switches, routers, adapters, hubs. These are the tools which transmit data. You see, your network is like many paths. It is like you see roads. Internetwork processors ensure that your data keeps traveling on the network. It doesn't get stuck anywhere. So these switch the data from one place to another. These route the data, create new paths. These are called internetwork processors. These are different kind of tools. Multiplexers are such kind of tools which divide your whole bandwidth into smaller bands, so that instead of only one data, many data items can travel. If you have, you can see that if you have an internet connection, it means you have a pipe. You have a path on which your data can travel. Now if you want to divide that path into smaller paths so that many data items can travel independent from each other, then you need a multiplexer. A multiplexer is like an interchange. You see, on interchanges, you divide one road into many roads so that multiple cars can travel. If there was only one path, only one car could travel. Right? So multiplexer is which divides your large space into many smaller spaces so that every small space can accommodate one independent piece of data. It allows single channel to carry multiple signals. Multiple signals mean multiple data items. Network management is done by network operating systems which run on the network servers. What is the topology? Topology is the way in which your network is designed. A particular configuration of your network means how your one computer will be connected with the other computer. There are three major topologies. One is called star, the other is called bus, and the last one is called ring. On slide number 35, we'll see the diagrams of all of these three topologies. Every network follows a particular protocol, a set of rules according to which one computer will communicate with the other computer. If there is no protocol, the communication will become messy. Any computer can access any other computer. It can steal data from the other computer. So, when you have a network, that network has to follow a protocol. If there is no protocol, then communication will become difficult. Just like if you want to use internet, that is also a network. Internet has its own protocol. It is called TCP/IP, Transmission Control Protocol, Internet Protocol. This is the protocol through which the traffic on the internet is managed. For example, if you want to use your computer to call someone, use your computer as a telephone, you use another protocol which is called VoIP, Voice over Internet Protocol. This establishes rules for using internet as telephone medium. So you have different kind of topologies: bus, star, ring, and you have protocols through which you manage your network. On slide number 35, you can see three major kind of topologies. The last one is the bus topology. As you can see, all the computers are connected with the server in bus topology using one single communication medium. So if this single communication medium is broken at the very start of the network, no computer can communicate with the server. This is the disadvantage of bus topology, but it is the cheapest and simplest kind of topology. On the other hand, you see star network. In star network, every computer is connected with the server independently, separately from each other. So if one connection goes down, all the other computers remain in connection. So your whole network does not break down. On the ring network, all the computers are connected with the network server, which is a different computer, and then this network server is connected with the server. This is a different kind of network topology. For a computer to communicate on the network, the computer is divided into 7 layers. This 7-layer standard model is called OSI, Open Surface Interface. Open Service Interface model. This model divides your computer into 7 layers. The outermost layer is the layer 7. On layer 7, you have the interface on which you give your data as input. And then this data is processed at layer 6. It is further processed at layer 5. Every layer does its own work until it reaches to the layer 1, which is the physical layer where the hardware exists. When it reaches layer 1, it is in the form that your hardware understands, and then it is transmitted on the network. So all the computers which communicate, from down to up, layer 7 is where you see the software, and layer 1 is where the actual hardware lives. Intermediate layers, layer 6, layer 5, they do their own work, add some kind of information with the help of which the data can be transmitted on the network. So layer 7 is the interface, layer 1 is the hardware. Well, what do we have more? What is bandwidth? Bandwidth is the capacity of data that you can send on the network. So it is the size of the pipe that is given to you. If you have a large bandwidth, it means you can send more data. Your small bandwidth, it means you can send small data. Switching alternatives, it is like the routes. So if like you have a switch, you can move to path A, you can move to path B, you can move to path C. The switches, the tools which are on your network, actually transmit your data on different paths. They keep on switching. They keep on sending data on the desired paths. Do we have anything else? Yes, if you have many networks communicating with each other, not just many computers, but many networks communicating with each other, just like many computers, you must also think that these networks have their own different resources, their own different operating systems, their own different machines. So how we are going to communicate one network with another network? Again, with the help of the middlewares, common procedures and protocols through which one network can understand the other network. This is called network interoperability. And this is where our chapter 6 comes to an end. Now I am going to open the chat, enable the chat for you, so that if you have any questions, you can ask those questions in the chat and I will try to answer those questions. You can type your questions now if you have any questions. I hope that you were able to understand chapter 6. We are in week 7, but the problem is that since there were not many teachers available in many campuses, so in the first week and in another week we could not give proper lectures. That is why we are 1 week behind schedule, but since now you have face-to-face teachers in every campus, from where you can study, as I mentioned, you can study from the lecture slides that I have given. You can study from the recordings that I have given. If you study the lecture slides properly, number 1. Number 2, you only study the case studies from the book carefully. And number 3, you do the assignments given in the blackboard. You don't need to read the book any further. Midterms, when will the midterms be held? I don't know. Have not been notified to me. Whenever these are notified to me, I will tell you, but what I can tell you is that I will coordinate with all of the teachers to ensure that midterms are held till chapter 6 that we have studied today. Yes, you should submit the assignments because these assignments will increase your knowledge. It's a very simple assignment, and we may be asked to grade these assignments at any time. Chapter 3 and chapter 5 are included in the midterm exams, and those will be taught to you by your face-to-face teachers. Well, when you submit the assignments, from next week onward in this virtual session we will be doing questions and answers. So if you have any questions, you can ask me about the assignments. I will answer those, so you will know if you have attempted correctly or not. The book is very important because these lecture slides are taken from the book. The case study is in the book. The assignments are based on the book. I don't know when is the midterm exam. Network interoperability is if one network wants to communicate with other networks. These networks may be different from each other. So in order to communicate these networks between each other, we need some procedures. Chapter 3 and chapter 5 is included in the midterm exam, although I have not created recordings for those because those chapters will be taught to you by your teachers in face-to-face classes. I don't know the date of midterm exam. If you have any confusion about any question, Mundira, you can always ask that question to me. So I will answer and you will know if it is correct or not. What is the most important thing? Most important thing is for you to read as much as possible. Minimum is the lecture slides. Then you should read the case studies from the book. And then you should attempt the assignments. That is all that I think that we will need. You don't need to read any further. Who will write the exam? All of the teachers will combine together. Yes, case studies are very interesting. Reading. These are like stories of the organizations. You can just sit down and read the case studies. You have my email address already, but if you don't have, I am going to write it here, m.ramzan@scu.edu.sa. I try to answer as many emails as possible, but most of the time I give you time here to ask your questions. If you want to just study the slides, that is the minimum that you should. You see, there are levels of improvement. If you just want to pass, the slides are sufficient. If you want to get even good marks, you should study the case studies. If you want to even get better than that, you should attempt the assignments. You see, there is always a level. Slides are the minimum level to pass. If you want A+, then you have to put effort. You see, A+ means the highest grade. For A+, you have to put good effort, right? A+ is the highest level. Inshallah, all of you will get A plus, inshallah, and inshallah, all of you will also study as well. We are going to study approximately 12 chapters. Thank you so much, all of you, for being in the class. And well, exam questions will be just like the assignments that are on the blackboard, but smaller and simpler ones. I shall be putting some such example questions in the next week's class, so that you can understand the kind of questions that you may have. Next week, I shall review, and inshallah, you will get an idea of what kind of questions you can expect from the exam. These are very small questions that are given on the blackboard, so you can easily attempt them and submit them. So now we are reaching at the end of the class. Inshallah, you will be having face-to-face classes. Which particular campus you are from, Doctor? Which campus you are from? The mom. At the mom, we have a teacher now, Dr. Nida Aslam, and she will be taking face-to-face classes from next week, inshallah. The homeworks which are given on the blackboard, that you should be doing. Apart from that, your homework will be given to you by your face-to-face teachers. I will not give any homework, but I will recommend. This is the last class of chapters. But if you don't have any face-to-face teacher in the next week, then I shall keep teaching. But I hope that we will have face-to-face teachers. I try to give answers in the email, but most of the times I try to answer in this session. Try to understand that it is not possible to answer every individual email. There are like 700 students that I am teaching, so how can I answer every single email? Some emails get lost, but I shall inshallah try to answer as many questions as you have. Khadija, I have just written my email address here. It is m.ramzan@scu.edu.sa. I shall be keeping on giving lecture. My virtual classes will continue, and anyone who wants to join it, it will be an honor for me to teach them. So I shall be giving the classes, and if you feel any confusion about any chapter, you will just ask me and I shall teach you. The assignments are on Blackboard, Khadija. You can get those assignments from the Blackboard. Thank you, everyone. Make good preparation. For your exams, and I hope that all of you will get your face-to-face teachers. It has been really wonderful, and it is wonderful teaching all of you. And I will always be here to answer your questions. Thank you so much. Allah Hafiz, and thanks.
تم إيقاف التسجيل.